There are 4 basic components of a human being. There are 4 basic components of a thing. It's the senses, it's the brain or the processor and model for the thing, and it's the muscle, the actuators, the things that actually change physical reality. And we have the most important component of a human being and of a thing, the internet connection. So with these 4, you will find these 4 more or less in everything. Not so much the actuators yet, but our other ones are more or less represented in all things which we call a thing. I will just briefly speak about, as you can see, I call this processor model because processor, that's the physical part of it, of course, the computer in the thing. But the important part of it is the model, because the sensors will just give data. And data by itself is useless. Data is like a foreign language which you don't understand until it's been translated. And this is kind of the elephant in the room for Internet of Things. There's a lot of talk about how much data we'll get from the sensors, but there's very little talk about our ability to translate this to something useful. So this is one of the, I think, I have an example from a guy who, he had 4 of these fitness trackers, wore them constantly, just to compare them for different brands. And they track how much you move in a day. And for simple translation, like this diagram is number of steps taken during the day. That's a fairly simple translation from data to let's call it information, to something which you can understand and act upon. But it's not a very interesting one, actually, because, well, steps taken, what's that? What I want to know is how many calories did I burn? Which these fitness trackers also provide you with information about. And they're all over the scale, because they all have different models for this. They have different tries to translate sensor data into something useful. So this is a tricky area. And of course, it touches at the user experience as well, because if you can't trust the output of these devices, that's not good. Or it doesn't matter because you're really not that interested in the exact number of calories you burn. You just want to see if you're doing better or worse, or you want it as a motivator. So in some cases, it's correct. It doesn't matter what this one says, just as long as the trend is right. It's a bit of confusion about, one of the reasons why there can be some confusions about what Internet of Things is that, well, this is a thing. This is maybe an archetypical thing. You have this lamp which can be controlled from an iPhone, so via the internet. So you can set the temperature of the light. And this is very simple to understand. It's very clearly a thing. In this case, it's an actuator, not a sensor, but still very clearly a thing. But most of the time, or more frequently, you will find these functions not as a thing by itself. If you're talking about the function, for example, the function of keeping your home at a comfortable temperature, it's split into several different physical items, things. The sensors are by themselves. Somewhere in your house, you will have a hub where the processor lives, or possibly all the heavy processing will be taking place in the cloud. So it will just be sent away over the internet to a more powerful computer, which will process. And you have the actuators normally located down in the basement to control the temperature of the heater. You also have the user interface for these things, which for the user often is what a normal user would say, this is my Nest. disregarding, maybe knowing, but not feeling and not regarding the other parts as anything worth mentioning. So the user interface will very often play the role of representing the thing or the function of the thing. And then we have the real thing. This is actually, I think, the more important significance of Internet of Things. Maybe not as exciting in some ways, and definitely harder to grasp, but it's an extension of what we can call traditional IT systems. For example, in this example, there's the traffic planning system of Skånetrafiken, which is a traditional stock-of-the-mill traffic planning system, which has been extended with the help of Internet of Things. So now this system also has senses in the form of GPS on the buses. So it has the sense, it knows where the buses are. It has a model, it knows how long time will it take to drive for a bus, normally take for a bus to drive from there to here. As everyone who's been waiting for a bus in Malmö knows, this model is not better than any of the calorie counter trackers. Sometimes it gets it right, often it gets it wrong, sometimes it gets it very strangely wrong. But still, it has the model. It does not yet have the actuators, but this is a matter of a decade, more or less, where we will have self-driving buses, and they will also be part of this system. So I would say that the important or the kind of things that will have most impact on our lives and on our society is the traditional IT systems extended with senses with eyes and with muscles. Also very typical for a thing of this kind is that we have user interfaces to it and that they are adapted to the situation. This is the most clearly example. Excellent user interface for this situation, standing at the bus stop wondering when is the next bus coming. But you can also check it from home. Can I slosh around a bit more, or must I run to the bus now? Or from your smartwatch. So this is also typical that we will find several different user interfaces, each one specialized on a certain usage situation or on a certain device in some cases. So for us working with this poses a number of different UX challenges. We will work less with administrative input. There is no need for humans to sit and type at the keyboard when the system itself has sense and when the system itself can read physical reality. And as the mirror image of this, there will be less administrative output since the system will act themselves upon reality. There will be a large part or an important part of the user experience which is hidden in the model. Very important for the actual experience for the user. And for us as a profession, this can be a problem because this is normally not an area which we are allowed into. This is kind of a technical area or for the statistical experts or something. So this will pose a challenge for us. How should we relate to the models? Should we try to say that it's very important, it's a very important part of the user experience, and it should be vetted or something by us? Or should we just give up and concentrate on the things where we actually know that we can have control over? There will be possibly more information and interaction between the system and the end user. Maybe not so much between administrators, but with the end user. And this must be posted in the most appropriate form at the right time through the right channel. So this will be like for a UX person, this will be the part of the UX Internet of Things which will be most fun to work with and maybe the largest part of it. To it's kind of a great time because we get to invent new user interfaces. We don't get just to reuse the computer screen and move a button up here and move a button down there. We must think what in this situation is the most appropriate user interface. So we'll have much more fun. As a final word on this, what is the Internet of Things, it's important to understand that a lot of the hullabaloo about Internet of Things is from a consumer technology perspective. For consumer technology, this is quite new. If you look at it from an industrial side of things, this is something very old. It's not been called Internet of Things earlier, but in the background here you see a typical, I don't know, maybe it's 100-year-old. It's at least 75. A system for controlling trains with sensors along the tracks, with actuators in the switches and the signals, with a user interface, which you see here, which is very much adapted to the situation, and with network, not internet, that should be said, another kind of network, but still a network. So all the essential components is, and this is not atypical, this is typical for industry. They've been working with automation for a very, very long time. They've been calling it different things. They call it point of sale system. They've been calling it machine to machine, process industry. So the only thing which is new, I think there's a kind of a bit of a surprise in the industry. I mean, Johanna can say tell because she's working with a company that's been working with this for ages, and suddenly, oh, we're doing Internet of Things. We didn't know that. So you will find a difference, quite a big, I would say, cultural difference between designers working on the consumer side of this and designers working on the industrial side, in the sense of automation of machines and such. So with this, I hope you're a little bit clear on at least what I mean with Internet of Things. You will find other definitions from other people. Over to the user experience. This is a very technical field. I have no idea how fast. It feels like I'm talking very fast. I normally do this at the beginning, and then I get a bit calmer and slow down. So I have no idea. But maybe you can kind of 10 minutes left or something. Then I will start talking faster again. This is a very technical field, of course, and it's very easy to start to have a technical perspective on what to do. We have these sensors, what should we do with them? And we have this processor and these actuators. Let us build a tea kettle that you can control from your iPhone. And you will find a lot of these things, actually, if you look around at the Internet of Things, where some kind of technology enthusiasm has driven away. There's even a website called Put a Chip on It, referring to the practice of taking an existing product, a toothbrush or something, and put a chip in it, and suddenly it has internet connection, and then you do a little app for iPhone, and you have an Internet of Thing. I'm making it easy for me with this example, because I'm quite sure this is the dumbest ever implementation of Internet of Things, and I say this well aware of that also someone has made a fart meter, which you have in your back pocket, which will present in very nice information graphic how often you fart, and it will do a chemical analysis of this and suggest changes to what you eat. But even in that perspective, I think the kettle is the dumbest. I would say that Internet of Things is a bit like, partly one aspect of it is that it's the new Second Life. I don't know how many remember Second Life. It was very much. Do everyone know? Should I explain what is? Yeah. Yeah, Second Life was this virtual reality, virtual world where you could have an avatar and walk around in it. So you could live a parallel life in this. And a lot of of companies and such spend quite a lot of money buying property in Second Life in this virtual world and building. For example, here is Malmö kommun spent, I think, 1.2 million kronor building a copy of Malmö in Second Life. Sundström spent, I don't know how much money, but quite a lot of money building their own island in Second Life. So this is the library in Malmö. And this went up for, I think, about a year before because by the time they had built this, everyone had oh, this is shit. What am I doing here? Everyone has woken up and said, what am I doing here? This is not real life, or whatever. And it was very much driven by not the user experience per se, but the feeling, I want to be a part of the future. And this was identified as the future. And it's a bit the same thing with Internet of Things. It's the future. What do we have in the future? We have iPhone-controlled tea kettles. And this attracts a certain group of consumers, the early adapters, for whom technology per se has a value. They're interested in technology. They want to know more about it. And they are willing to spend quite an amount of money, some money, and quite an amount of time to configure things just the way they want it and to get it right. And they're very tolerant towards errors in the things, because they know this is new, this is not perfect yet. This is not at all typical for mainstream consumers, meaning that there is a trap within Internet of Things. Early success can be a trap, because early success can mean that you have reached the early adapters, which is very nice. It's very nice to have customers. And you can say, oh, this is taking off. And then you reach to mainstream consumers and it just blows up. What? This went so well. Because this group of early adapters is quite a small percentage of the consumer population. So, how do we avoid building the Internet of Stupid Things? Because honestly, many of these smart things are quite stupid. Well, we could take a traditional UX approach to this, saying that let's start with the user. This is what we do, more or less all of the time. Say, for whom do we want to do it? What is the user goals? What are the business goals for this product? And work backwards from there. With this, what functionality do they need to achieve their goals? And what model, what data is necessary for this to work? And from that we can draw the conclusion on what sensors should there be. So this is a solid model. We're using it more or less all of the time, most of us, in one version or another. I hope. So it's kind of an ideal model, but it does have a problem. It's not a very innovative model, actually. It's quite hampering, because in a field where the technology moves very rapidly, technology by itself is often the inspiration or the source of ideas. The picture here is if you donate blood in some parts of Sweden, and this blood is used for a patient, you will get an SMS saying, "Thank you for donating. Your blood has now helped the patient." So this is a fantastic idea. At least I feel so, because it's such a motivator. So and you feel really, this has been for one human being a good thing which I've done. And I would dare to say that this is an idea which no UXer would ever come up with. No, that's wrong. A UXer could come up with this 10 years ago or 10 years from now, or maybe now, random will decide. Because if we only are thinking of user needs, then we don't know, or we don't have in our perspective, when did this become possible? 10 years ago, it was not possible. It was a good idea, but there was not the infrastructure to do it. Well, 10 years from now, it still will be possible, but it will be very late to the party to come with the idea then. So this is a field, I would say, that is, I would call possibility-driven, meaning that you have to have very good knowledge of the technology and the possibilities opening up from technology to actually be in the front line or be innovative. So the user cannot actually be a creative driver for this. So I've fixed your discussion for the Q&A session now. Instead, I think we must use a model where we start in the technology, in the possibilities that opens up. And this is like, oh, this, and look wide, see. This is a number of possibilities. And then we must combine this with user-driven, user-oriented focusing process to select, to weed out the good ideas from the tea kettles. If you have been working with design thinking or any model based on design thinking, this is nothing new. For they typically have these stages where you switch between open up, collect as many ideas as possible, and then narrow down, focus. And you will recognize this, and you will find this kind of design thinking is I would say you will find it in most methods we use in service design, and all of those which I've just dropped the names of right now. I think which is very important when designing for Internet of Things is, it's always when designing important to understand the user. But in our case, this is from a lovely Swedish film where they actually went around in lonely Norwegian men's kitchen and made a study of how they lived. With Internet of Things, not surprisingly, the environment in which the thing is used is extremely important for understanding. Much more so than when you design for computers, or a bit more so than when you design for mobile phones, because you must know things like this. Is the user doing something else at the same time? Use of things is often done in a social context, meaning that you are watched while using, or you do it in a milieu where there's other people around you who can see what you're doing. While using a computer is often much more private. This is why you will not see Internet of Things porn. Yes, you will, but actually. But you will have also shared usage of these things. Many of them are used, at least shared within a family and possibly within a workplace. And some of them are public, so to say. We have smart parking lots, which is very much shared by every car. And also a thing which is changing as we do this in the environment is that there's a lot of things coming out to it. It's not only the thing you are designing, it's the things that everyone else in this room is designing. So there's going to be a lot of things which are demanding our attention. And this also has to be handled in the design process. So I think in your toolbox, I would recommend that you put user journeys. This kind of, okay, in this use case or this user, what is the starting point? What is the motivation? What is the actual actions for things? And do not forget the setup in this user journey, because that's often a very frustrating part of using a thing, getting it actually to connect to your Wi-Fi and connect to the cloud service and such. And experience maps. But these are methods which is kind of holistic, or trying to use the context or the environment of the usage in the understanding. So, and I think that's especially important when you design for Internet of Things, that you would not just focus like, I come from a background where we did much studies, just we took one person, put him or her in the conference room together with one computer, and then Johan, who sits here, would sit beside the person and ask questions. I would sit behind and make notes. And this kind of testing will not fly for Internet of Things because it's too. That's not the kind. It's not a very good one. It's an economically efficient one for computers, and it's decent for computer applications, but it's not. It's missing too much. So you need to have more holistic methods. It's also so that many of the things are not isolated in their task, or what they're trying to do. For example, this is a medical patch which you would put on your skin, and it will read heart rate, amount of sweating, I think, other things. It's a sensor which you will wear, and it will communicate, if I'm not mistaken, with your phone, and it will send data to your doctor. So it's like continuously monitoring you. And this is just one touch point between you and your doctor. You have when you come to visit her or him. You have phone calls with other staff in the hospital and so. So the thing is in a context of is one touch point in the context of many touch points, and they are part of a service, which is why I would say that service design has quite a good fit for Internet of Things, at least for some of them. Just not in medical situations, also in, for example, shops, where you have this iBeacon system, which will bring you extra erbjudanden, whatever is that in English, special offerings to your phone while you're shopping, or if you're trying to leave the shop without having bought anything. They will buy, come back, and I will give you this. Only because you are my friend, I will give you this for half price. It will say. Prototyping is already a very important part of our jobs, and it will be most definitely, since we want to test the things as realistically as possible in the environment. It will be an important part of Internet of Things design. Unfortunately, the situation is quite good. We have Arduino and similar sets, and we have 3D printers. So quite cheaply, maybe not so simply, but quite cheaply at least, you can make very high-speed prototypes of things and test them in real life. But do not forget the value of the quick prototyping, of the low. This is from IDEO, and I designed some kind of paint brush-ish thing. And I wanted to just get a feel of how will this work? Is this the right basic idea? So this is like paper prototyping, but for Internet of Things. I myself am a very huge proponent of paper prototype. I think the idea of prototyping is the quota. How much effort do I put into this, and how much knowledge do I get out of this? So the less effort you can put into something, getting some knowledge, the better is the quota. So the better is the prototype. If you are in luck, if you work in some companies, which has this as part of their strategy, many of us who work with the web would look at Google Analytics, if there is already a website, look at Google Analytics and learn quite a lot from it. And things have the ability to call home, to report their usage. So you will have the actual usage of things. You can have a kind of Internet of Things analytics chart to start from as a basic one part of your understanding when you're doing the next model, something. this is, of course, a bit tricky, not uncontroversial. How much can we spy on people and such? Some things are even possible to remotely configure, and therefore they can be used with A/B testing. Like, okay, what happens if we change this configuration like this? What effect does it have on usage for a small part of the thing population, the product population? And then, oh, it went swell. Then we roll it out for everything in the next update. Or, oh, shit, it blew up. Then we'll send some letter of apology and a check to the few users. And then we will just bury this idea. This is very powerful. I'm sure many of you have met A/B testing and seen it's a very powerful tool in the UX toolbox. This here can be said to be your development process. At least mine looks like this, like that. Your might be more smooth sailing. I don't know. And this is the point when production starts, when you have to give things to the factory, so to speak. Which means that for all you agile lovers out there, you're out of luck. Because Internet of Things is the return of the waterfall. Sorry, you spent the last 7 years or something learning agile, but that's not relevant anymore. Back to Roop. Maybe it's not that bad. But there are physical products by its nature has many more dependencies than software production. Especially this is true for consumer products, not so much for advanced industrial products, which is often made on a one-to-one and with very much configuration around each delivered product. But for consumer products, there are a lot of things which is non-agile by their nature. You have fixed delivery dates, so to say, fixed dates when the final product, the nice product, should be out, and these dates are counted backward from next Christmas, because you have to be out for Christmas, or you can just take another year developing the product. You don't leave a factory standing waiting for something. You have a production slot which you must make. Because otherwise it will be costing an enormous amount of money for no good. And there often is an early lockdown of features because they have to be communicated. They have to be described in the documentation, in the information to the retailers, sometimes at marketing events, mässor, whatever that is in English. So all these are factors which tends to say that, okay, we will have to. There's more. It's also very hard. One of the basic ideas of agile is this continuous improvement of things, which is not. This does not play well with the logic of physical or the marketing logic of physical things, which is very much more based on you have one version which is out now, and then there is a significant difference to the next version, which means that you can do this marketing new and shiny thing when you start to sell it again. It's a way of revigorating the market because they're going to pay. I mean, in software they don't pay. They possibly pay a subscription fee, but they usually don't pay for the smaller upgrades. So you want to have a significant step. Agile is not. It's still if you feel very sad after the previous two slides, I could say that you can still use agile philosophy during prototype stages, and at least for products which are essentially computers. So hopefully I made another subject for your discussion. Maybe we'll see. When dealing with physical products, mistakes are expensive, especially if they're discovered late in the process or or worst of all, if you have to recall a product, meaning that there's a high cost for mistakes, which hopefully means that there's a greater motivation for throwing money at us for testing and for thinking things through before they go to production. At least it makes economical sense and could be argued as such. So, how does design for Internet of Things differs from digital design? That was the ones I spoken about earlier. Previous now that's more methods, the methods that we use. And now the actual differences. One very important difference is that computer interaction is eye and to some extent ear. It's vision and it's sound. While Internet of Things interaction is haptic, it's acceleration, it's the presence of a body in a room. It's possibly brain waves. This can be used at computer as well, but it just reads your thoughts, so you can actually control things, at least simple things, and not so simple things. I saw one woman in the United States who was flying an F-35 combat jet fighter, and she was paralyzed from the neck down. She had no movement arms and legs, and she controlled it entirely with a more sophisticated version of this. They're just letting her fly in the simulator. So, but my understanding is that she is actually not crashing the plane. She's flying them quite well, but still, I think someone wanted to place her in a I don't know what this is like a third of a milliard Swedish crowns. So someone went nervous. So no, she stays in the simulator. I also saw recently that you can actually put electrodes behind the ear here and send, as they say, harmless electrical currents into the brain, and it will affect your sense of balance when you build simulators. You can feel like, oh, I'm going here, I'm going there, while sitting right up, just because. So there's a lot more possibilities, which of course means a lot more fun for us. A special thing when designing for things is that you'll find that focus of the user is often somewhere else. This is one of maybe the oldest Internet thing in public use, in widespread public use, the GPS, which has all the components, so to say. It has sensors for location. It has the user interface, and it has a wireless connection. It even acts on its own. If the car suddenly stops, very suddenly stops, and there's no moment, it will by itself. Some models will call 911 or 112 and say, "Probably, I have probably crashed, and my location is." But this is very typical because it would be dangerous for this one to have the expectation as a computer that you would look at the screen. So therefore it has chosen another sense, another way of communicating with its user by voice, which is more appropriate for this situation. And you will find that many things, to a much higher extent than computers, has kind of symbiotic relation to the user. It will cooperate with the user, often in the form that the thing is the one which is taking in the data and analyzes them and translates them to form suitable for a human being. But the human being is supposed to be the one who takes the actual decisions, and the human being is, if you want to be cynical, you can say that a lot of things are using the humans as actuators. It's like a crime team with the thing as the brain and the human as the muscles. Further on, our specialty, building interfaces, semaphore. Technically, you could argue that interfaces are, most of the time, all of the time, are sensors. in a technical sense, but of course they are still a special category, an important category when people are using things. The biggest difference, I think, is to realize that men are mice. That normal computers you normally control by a mouse or the touchpad, into things you would often control by your presence, by moving in the room, by entering the house. You would affect the thing and it will act appropriately. To some extent, while this has not been worked so much on, also body language will be part of this. And in the cases where the thing needs to know, I mean, presence is good for some applications, but it's anonymous, so to say. It's hard for the thing to differ one person from another, should that be needed for the application. And since we don't have barcodes in our foreheads, and I would not be surprised if I now ask, is there anyone having an RFID chip under their skin? Not that kind of crowd. There is also these pure Internet of Things meetings here at Foo Café, where I know at least 2 persons which has it. So they have a permanent ID, which they could hold up to a reader some meters away, and they will be identified. Most people are not willing to do this, but we are willing to do something else. We are carrying around our mobile phone all the time, and this can very efficiently be used as a tag, as a way of identifying individuals from each other. And it can also have other usages for a thing. For example, thing called geofencing, which is geological fences. It's not actual fences, but it will notice if you are, what area. Your phone will tell the thing that, oh, he's heading home, or at least he's heading homewards. Time to go out of energy efficient mode and start heating the house, so it's a pleasant temperature when he gets home. This interfaces, which is mostly based upon your presence in the room, or your body language, or things which you do anyway without thinking so much, are often referred to as zero interfaces. And this is something new. I don't think we're working with zero interfaces in any other field of user experience. And sometimes we're not even aware of these interfaces. They will go into the background and we'll not think about them, or maybe we will not even know about them from the start. So we have one design bureau in Malmö. Is anyone from top here? No. Which is very much a proponent of this, arguing that there will be so many things that this is a necessity. I myself is a bit not skeptical to the idea. I think it's a very sound idea and very sound principle. Bother the user as little as possible. But at the same time, I've been using a PC computer with a virus protection program. Virus protection programs are excellent for zero interfaces, because there's no need for the user to be involved. They could just download the virus definitions, do the scan in the background, and not do a sound before, unless it discovers a virus. Then it would say, "Hi, user, I have something I must discuss with you." But what do? They put up large dialog boxes with a thermometer which moves ever so slowly, and the text which I'm scanning lots of files, and now I'm downloading new antivirus definitions. And why does it do this? It does this because of what we in Swedish call blyga pojkar får inte kyssa vackra flickor. If you are too timid, you will not be noticed. And if you're not noticed, your brand will weaken, and you cannot at all be sure that the user will splurge the money for the next version of your antivirus program. And I fear this might be the situation with many things as well, that they will, for purely branding reasons, they will bug us with their presence. I'm here, I'm doing good things for you. So, how will we control the things? One thing which is often argued is that gestures would be ideal for this. That this is kind of a vision that, oh, I have an excellent idea. Why don't I lift my hand from the touchpad and control the computer from here? And it is kind of an excellent idea, and I don't believe in it. It does work well for some gestures, some which come naturally. But even these are problematic because they are almost all of the time cultural gestures. There's a great difference between there's very few gestures which is actually global or intercultural. And gestures as a control works very well if you have one or few things, but they do not scale well. They're quite cognitively heavy, so to say. They put a cognitive load on the user because, no, let's see, how did I do this? How did I shut it down? No. Oh shit, no. And there's a lot of things listening to you at the same time, seeing you, your gestures, and they have to differ from each other. And you have to remember gestures for different devices. So I don't think it scales very well. This is the Nest, same ones who's doing the thermostat is also doing a fire alarm, which is, as you know by experience, all of you out there today, if you're frying something in the kitchen, the fire alarm will go off. And it will not just go off, will scream. And you start to climb up to remove the battery. So, and I thought, oh, we can do this better. Let's do this. Let's do this. Shut down. So it had the sense of, oh, someone is telling me to shut down. Problem they realized later. I think that this was after the first version or something, was that when there is fire, people tend to do like this. My belief is that voice will be the major, or at least a major interface for the Internet of Things. I think Siri is providing that it can be fairly useful, not as bad as if I hadn't known Siri, I hadn't tested Siri, I would say this will never work. But actually, I think it works impressively well, and it's getting better. So I think voice will be an important part of it. I also think that buttons, levers, knobs. Okay, this is not a new idea. Actually, it's one of the oldest ideas ever for machines, that you should have a button or a knob or something on it to control it. But it's a good idea. It still works. It has several advantages. It makes a kind of direct connection, or you can it's easy to build a mental model for a knob or for a button. Say, if I press this, that will happen. It gives us the chance to put labels on things, which is good UX, which lessens the cognitive load significantly. Buttons they have their limitation. They are almost used, as everyone who's been trying to use a remote control for the TV knows, that they are useless for more complex interaction and configuration. Meaning that for a thing you can put the main tasks, so to say, in buttons or levers or knobs or whatever, but you can't do this. I will hound you down if you do this. So another important part of the interface for Internet of Things will be the apps in the smartphones and on the iPads and on the tablets. Typically used for configuration, for complex action, for there's within the Internet of Things community or whatever. We do love infographics. A lot of Internet of Things. Oh, we have a lot of data from the sensors. Let's put this. Let's make circles of this in different colors, signifying different things. And you will find these versions of this more or less for every single Internet of Things thing you can buy. You can also put it up in your iPhone and get staples and diagrams and circles and stuff. This is perhaps possibly more driven by, oh, we have the data, but we must do something nifty with it. And also it looks good in marketing material. Apps is also very useful for remote control of things, of course. If you want the thing that you're not in the location, you are in your bed, you're just waking up. Then you go for your phone, and you would look up the app, and you said, "Tea kettle, start boiling me water," and it will. So I would dare say that this is one of the discussions you will have should you start to work with Internet of Things at a company, where someone will say, well, let's drop the buttons, let's drop the nodes. This is just steampunk nostalgia to have those on our nice things. Let's control everything from the phone. And you will argue, no, that's a terrible idea. Listen, every simple thing you want to do, you would have to pull up your iPhone, look through millions of Internet of Things apps, which you will have. Find the right one, open it, possibly go to the right section also, and then do the control. So terrible idea. No, but it's cheap. It's cheap, and people can do it remote. This is your future. This was a discussion, extempore from your future. This is the slide I fear the most because I don't know how to pronounce this word. But is anthropomorphism a good idea? Anthropomorphism is things that behaves like a human, or possibly like an animal, behaves like it's anime, like it's alive, and looks like a human or an animal, and talk. This is kind of controversial. There's quite a lot of strong feelings around this. If this is a good idea for machines to kind of pretend to be humans, or if it's a better design that they are machines and spin on their strengths as machines instead of being a second-rate human imitator. My personal view is it's an excellent idea. Because humans relates, it's been shown that human relates so very strongly to anything that looks human-like or animal-like. This is from Iraq, where there was quite widespread use of robots. And not only did the soldiers name their robots, and they founded quite deep emotional bonds with robots, even to the extent that in some cases soldiers risked their lives to save their robot. So this is of course, this is a problem. In the other end, the other side of the problem, in some situation, this can work too well. In this situation, it worked too well. They got a too strong emotional bond to the robot. And also, it's been shown by research that the more human-like or animal-like a thing is or a machine is, the better is the emotional response, until a point where it suddenly drops down to a negative response. And this is called the Uncanny Valley, or the zombie zone, where something looks like a human, but not quite. Something is a zombie, something is wrong. It's a human, it's not. And this can be, so there's a danger in doing this too long, and then it goes up if it's perfectly human-like. It's supposed to go up again, but no one has constructed such a machine, so we don't know that. So they should, my view, and I know other people have other views on this, is that if possible, we should build machines that is fairly human and animal-like, but in a sketchy way. So clearly machine, but still, because the tendency to form emotional bonds is actually very strong, and we do it. Sketchy is enough to do this, while this is taking it too far.